Hey guys, this is a YouTube channel that focuses on teaching high yield medicine under 2 minutes. So this video today most likely won't turn out to be a 2-minute video. So today's video is going to be on immunosuppressant drug. Mostly in detail we're going to cover the mechanism of the most common immunosuppressant drugs. So let's get started. What I've drawn here is a T cell. So the thing you're seeing in blue is T cell, and above in dark blue is T cell, and above it in light blue is an antigen presenting cell. So we'll start. You can watch this video on 1.5x if you feel like this video is going too slow, because I'll be drawing while explaining. And an antigen presenting cell will have receptors of its own, and this receptor, and let's draw the receptor for T cell. So antigen presenting cell is gonna present antigen to T cell. Yeah, suppose this is the antigen. I need a darker color. This is the antigen, and as soon as it presents the antigen, in the next step of the pathway is that you get calcineurin. So that leads to this is a dumbbell shaped this thing. It's not actually dumbbell shaped, or if it is, I don't know, but this is calcineurin. Okay, and calcineurin goes and activates this thing called as NF80. NF80 is nuclear factor of activated T cells. Nuclear factor of activated T cells goes inside the nucleus, and it causes IL-2 gene transcription. So basically IL-2 mRNA is produced from the nucleus, goes into the cytoplasm, makes the IL-2 protein. And so the next step would obviously be IL-2. So this is IL-2 molecules, and these IL-2 molecules will go out, and they'll go out on the same cell or on the adjacent cell. What they do is, this is the IL-2 receptor. These molecules will bind on the IL-2 receptor, and they would produce, and when the binding of IL-2 with the IL-2 receptor happens, it will lead to the production of this thing called as mTOR. And mTOR is basically, suppose this is mTOR, this tie-shaped body. And what mTOR does is it goes in the nucleus to cause cell growth and proliferation. Cell growth and proliferation. Alright, so what else is required for cell growth and proliferation? Obviously, for cell proliferation you need nucleotides, so we'll keep nucleotides in the picture as well. Nucleotide synthesis. So the cell is gonna synthesize nucleotides. That's gonna be again required for cell growth and proliferation. And last thing to add up here is NF-kappa B. NF-kappa B is nuclear factor kappa light chain enhancer of activated B cell. So this protein, it is NF-kappa B. NF-kappa B would go also inside the nucleus, and in the nucleus it will cause inflammatory gene. So basically NF-kappa B also is responsible for the production of IL-2 and other inflammatory thing. In general, NF-kappa B, whenever there is NF-kappa B stimulation in the nucleus produces IL-2, basically the IL-2 mRNA, and an overgeneralized response which causes inflammation. So we'll just write inflammatory genes transcription. So this is what we have got here. Okay. This is this is probably nucleus. This is inside the nucleus, and so yep, we'll start by each immunosuppressant drugs. So for starting from the left side, calcineurin. So calcineurin inhibitors which inhibit this are cyclosporin and tacrolimus. Okay, so they both act over here, inhibit calcineurin, and the next drug is gonna be inhibitor of mTOR. It is sirolimus. It is an mTOR inhibitor. Cyclosporin and tacrolimus are calcineurin inhibitors, and so I told you for cell growth and proliferation you need nucleotide synthesis. So what's going to block nucleoside synthesis, particularly the pyrimidine purine synthesis, is through drugs which are meclofenolate and azathioprine. It's called azathioprine, but you can remember it as azathioprine. So you know that it inhibits purine synthesis, and the difference between both of these is meclofenolate stops IMP to GMP, which is used in purine synthesis, and azathioprine acts is basically it's a false purine nucleotide, gets incorporated into the DNA as false nucleotides, so basically leads to improper DNA formation. The difference between them is meclofenolate is particularly acts on lymphocytes, because what happens is in other cells when you block this is produced by a salvage pathway, whereas lymphocytes do not have a salvage pathway. So meclofenolate is specifically used for lymphocytes, whereas azathioprine overall leads to what do you call a suppression of any actively proliferating cell. So when you give meclofenolate to the patient, you see the decrease in lymphocyte count, whereas if you give azathioprine, there will be an overgeneralized pancytopenia. And the last drug over here, which acts on NF-kappa B, is a popular drug. Glucocorticoids, I think most of you know that. Corticoids, they act on NF-kappa B. So that is overall in a flow chart where various immunosuppressants acts. So I guess that is it.